All right. So let us do a little bit of research in this particular, delay functions. So what we'll do is, instead of giving inbuilt delay function from the, program, we'll write down our own functions and we'll try to understand. Okay. So for that, what we can do is, let us write down some functionalities here. Okay. So let us say we are going to, define some functions. So we can write it down as functions. Okay. Now function declaration, you have to declare some functions. So for that, what you can do is, you can write down, I want to write down delay my function. Okay. So void delay my function. Okay. And then it will be having unsigned long integer that will be taking up. So this is how my function is defined. All right. Now we will have variables to do that job. Okay. So what we can do is, let us say we can write it down as, this way you can, write down a very good method. So you can write down your variables. So while building the code, we will be also utilizing the same, like all the functions will be written below this, all the variables will be written below this, like that. Okay. So now let us say we are going to write unsigned delay, unsigned long delay. Okay. Delay value. So we have put unsigned long delay value. Got it? Now we are going to define this function. So to define this function, what we have to do is, we have to do function definitions. Okay. So in function definition, what we can do, we can go anywhere. If you want, you can write down like it should be out of main loop. Okay. It should not be inside main. Okay. So what we can do is, we can write it down as my void delay function, delay my function unsigned long delay. Now since our this delay does not vary during the programming, so that's the reason we are going to write down this function. Okay. So let us say we have already delay time, that is, put as, inside. So what we are going to do is, we are going to do while my delay time is greater than 0, what you do, you keep on calling the delay millisecond itself. So this one I will call for 1 millisecond. Okay. So let us say delay time is put 200. So this delay time will be 200, greater than 200 for 200 times. And now we are going to set this delay time decrement by 1. That's all. So it will keep on running, and it will keep on calling delay millisecond for 1 millisecond, and it will run 200 times. Like that it will happen. Understood? So hope you have a very good understanding of how to write the delay function by yourself by utilizing the same inbuilt delay function. You don't have to utilize timer for this job. Okay. Now instead of calling for this delay function, I can call my delay function. Okay. So you can write it down, delay my function 1000 times. So this will call delay my function, and then it will happen. So once you just go to run, yes. So good. We are now happy to understand that how we can write down our own delay function and how we can make use of this. Okay. So you have written 1000. Let us say you want to write it down. Let us say delay value. Okay, so delay value times you want to call. So delay value you have to write down. Okay, so let us say why we are going to utilize this is delay value can be a defined value for you, and you want to like keep on varying or something like that. Okay, so let us say delay value is equal to 200. So 200 it will call. Now you vary this delay value to 500. So each time you don't have to vary the number. That's the benefit of having the functions. Okay. Now let me quickly give it to you an understanding of how you have understood about ADC value. So suppose you want to read the ADC value and you want to see what is the value that has come. Okay, so for that purpose what we can do is, first of all we will try to find out which ADC value we want to read it. Okay, so let me just come here in the circuit, and as you can see we have ADC pin that has been assigned as PA4. So PA pin 4 is one of the ADC, and if you want you can quickly go and see those ADCs. So let me go to the table of content. It will be easier for you to understand. Okay. Okay, so we have, let us say, temperature sensor. So in temperature sensor you can see we have RA4. So RA4, that is port A pin 4, is reading the temperature of this particular sensor. Okay, so we will just try to read that value. So what we can do is PA4. For that you can go to your ADC, go to this adc.h, and you will see lot of functions that is there inside it. We have channel like A4, then channel B5, then channel B7, then channel C0. Okay, so you have to see which one is your channel for this PA4. Okay, that is first thing. Another thing is you have to put it like ADC result get result on conversion. Okay, so get conversion results, this is the function that you have to call. Okay, so ADC get conversion result, this is the function that you have to call, and you have to ask for the channel name. Okay, so ADC get conversion. So what we can do is, all right, so basically what you have to call is, you have to call not ADC conversion on result, this is a void function. We will be calling ADC get conversion, and we'll feed the channel name. Okay, channel number. Okay, so that's the understanding we should have. So what we'll do is we'll copy this function, and come back here in our main, and we are going to write ADC code and just get this ADC conversion, put down your channel number. Okay, so that's the understanding it will have. Now to get the ADC like number, we are going to go to PA4. So PA4 is here. Where is that PA4? Yes, PA4 is here. So you can see we have PA4 here available. Now come back to resource management and go to ADC. So you can see like RA4 is here, and the channel name, either you can call it as ANA4 or channel ANA4. Okay, so this is how it will be called. So we have to call at channel ANA4. So go back to here and write down as channel ANA4, and this is how it is going to read your temperature analog sensor ADC. Okay, so that's all. Similar to that, if you want, you can call ADC get conversion a corresponding channel names. So right now I'll give you an explanation with one of the ADC, so that you can have a proper understanding of how to call ADC. Now let us do a little bit of like changes in here. So what we want to do is, we want to store this value in a variable. So let us say we want to store this in ADC like a result value, result, or temp we will put it. So we are going to put it inside ADC result temp. So for that we have to put this as a variable as well. So as I have already told you, like you can initialize this particular value as a variable. So what we can do is come back to here variable and write down your variable. Like I will put it unsigned 16 bits, unsigned, or you can write it down as like this, UINT 16 underscore T. So this is the like functionality like this, and then put it as ADC result temp. So ADC result temp will store the value that has been read at analog channel 4. And if you want, you can take some decisions. Okay, so what we can do, let me give you a very like nice idea of how to make use of this particular functionalities. Okay, so what we can do is let us say we want to write down some if statement. So this is how you like make your results little bit complex. So if my temperature is little bigger or smaller than some value, let us say I'll just put it as 500, because it will go to 1023, that right? So this is, let's say this is a 10-bit ADC. We have to check out whether it is 10-bit ADC or 12-bit ADC. So that we have to see. But anyway, 500 will do the job. If it is 12-bit, you can go up to 12-bit. Then you can go up to a result of how much? 4095. And if it is 10-bit, then you can go to 1023. So you have to make sure like what is the bit value of this particular ADC, and in that way you will be able to find out. Okay. Now what we want to do is, if my ADC result temp value is more than 500, I want to switch on one of the LED. Okay, and similar to that, if it is less than that, I want to switch that off. Okay, so that's the understanding we want to do. So let's get into the one of the LED. So let us start with where is my LED? Here. So anyway, first three LEDs we have used. Let us say we will set this one RA0. So if this is like greater than 5, I'll put as IO RA0 set high. So understood. Now you are having an understanding, like if my ADC value result which has been read is more than 500, maybe it will be having some analog value corresponding to that I don't want to put it now. Then that LED will glow. And what you can do now, you can put else keep it low. So you just put that RA0 as low. Understood? So whenever my ADC value will be greater than 500 count, that LED will glow, and whenever this is less than that, then it will be set low, like it is not over. So whenever your LED is glowing, you will see that, oh, my temperature has increased more than 500. Okay. Now you run the program and you will see your code has built up. So if you have any problem regarding the reading ADC values and all, you can utilize this particular code. In our next session, what we'll do is we'll try to configure each of the ADC channel, and we'll do some functionalities like this only, right? So we can set based on the value of like ADCs, some LEDs high or low, so that can be having a very good indication for our programs. Okay. Thank you guys.